Hello, I'm Dr. Douglas Fitzovich of the Pikeville College School of Osteopathic Medicine, and this is Section 8 of Physiology, Acid-Base Physiology. Acid-base regulation permeates many areas of physiology, as well as, of course, pathology. Now, there are several points about it that are very high yield for the USMLE. You must know how to do diagnosis of the four primary disturbances. Those are respiratory acidosis or alkalosis and metabolic acidosis or alkalosis. You need to be able to recognize a combined disturbance, also called a mixed disorder. You need to know the compensations for each of the primary disturbances. If a patient has a respiratory acidosis, how do the kidneys compensate for that? You need to be familiar with the Davenport diagram. It looks highly complicated, but it's not a threat. It's a tool that you can use to help you diagnose acid-base disorders. And then the use of the anion gap, also called the plasma anion gap, in order to distinguish between different possible causes of a metabolic acidosis. These are the basic concepts involved in diagnosis of acid-base disorder. First of all, respiratory changes are very easy to recognize because they are reflected as a change of arterial pressure of carbon dioxide. All you need to know for this is what is the carbon dioxide pressure, and you will know whether or not respiratory function has changed. Now, changes of arterial carbon dioxide also cause changes of bicarbonate. However, it's important to notice that these are small changes of bicarbonate. So an increase or decrease of CO2 will change the bicarbonate concentration, but not much. Metabolic changes are defined by changes of arterial bicarbonate. They result in large changes of bicarbonate ion. And here's a very important point about this, that there is a metabolic change. If you look at the CO2 and say, that CO2 does not account for the change of bicarbonate. So you always have to evaluate bicarbonate in terms of the partial pressure of carbon dioxide in the arterial blood. Fortunately, for most conditions, and especially those that are high yield on the USMLE, if they want you to conclude that there has been a change of metabolism, they will give you a large change of bicarbonate. So remember, small changes of bicarbonate may occur as a result of a change of carbon dioxide. If there is a large disruption of bicarbonate, there has been a change of metabolism. And the other point is compensation. Compensation acts to restore normal pH. However, even the best compensation only partially restores arterial pH. It won't take the pH all the way from an acidotic state and go to an alkalosis. One of the most common mistakes made by students is to believe that the patient started out acidotic and as a result of compensation actually went too far and the patient became alkalotic. Don't do that. If the patient is acidotic, look for a cause of the acidosis. Another point, difference in time frame. Respiratory compensation for metabolic disorders is very rapid. It starts within seconds and can be nearly complete within minutes. That means that it is very uncommon to have a metabolic disorder that is not compensated by respiration. If you have a metabolic disorder and the patient is not compensating with a change of respiratory rate or depth showing up as a change of CO2, actually then you also have a respiratory problem. Now, turning it around. If you have a respiratory problem, the renal metabolic compensation for that is slow. You only see significant compensation at about 24 hours, and it can take 72 hours to reach the full effect. So it is quite common for the USMLE to give you a situation of acute respiratory disorder which is uncompensated by a change of metabolism. Because with acute respiratory disorders, there's simply not been enough time.